Hello, welcome to Ekidel, where I will train future civil and structural engineer. My name is Justice Onwaka, and I am your instructor. Today, I will be showing you how to design a slab raft foundation on this 8-story building you are seeing just here. Now, one of the things that we will do on this 8-story building is how to model a wall load on a basement wall. As you can see that this 8-story building here has a basement wall. Then from there, we will then move into the modeling of slab raft foundation in Protastructure. And then we will then proceed to the slab raft analysis and design in Protastructure here. So you have three things you are going to learn from this 8-story building. Meanwhile, this 8-story building you're seeing here is actually a course video. So if you want to purchase the complete course video, you can check on the link down below. And most of you that have also purchased before that are having issues and all that in downloading, yeah, you can join Ekidel membership here on YouTube. All our videos are there too. So either you purchase or you join. But if you're joining, know that you are going to join the Ekidel membership level based on junior engineer, because only in that area that this course video is being added. Now, proceeding, if you are new on Ekidel, please consider subscribing. And if you are an old subscriber that's at least stayed for 1 year with us here on Ekidel, please, I would advise that you join Ekidel membership here on YouTube. Now, on Ekidel membership, all our videos are structured based on the levels of engineering, knowing that engineering level starts from when you are a student. So we have student level, then we have final year student level, which also merge with internship students. Then we then move on to junior engineer, intermediate engineer, and then senior engineer. So please find your level on these levels, because videos are made based on these levels. Knowing that if someone that is still in year 3 or level 300 in the university is watching a flat slab design, it might be confusing for him. So with that, we have structured all our videos based on the levels of engineering, beginning from students to senior engineer. Okay, that's fine. So let's now begin right now for what we have for today, and we will begin first on the modeling of wall load on a reinforced concrete basement wall. Okay, let's begin right now for what we have for today. I love you. Ekide loves you. Okay, so from here right now, as you can see, this is an 8-story building, as you can see here. So let's now proceed now to model the wall load on the top of these basement walls, okay? Because you can see right now the wall loads here are missing, okay? That's fine. So to model a wall load, you just click on the wall, all right? Now, before you apply the wall load on this wall, the first you must do is to find out the height of this story. Now, if I hover my mouse now on this column here, you can see that the length of story, which is equals to 3875. Okay, now also the depth of this beam here is what you can see there, 650, which is h equals to 650. So with this now, if we subtract 3875 minus 650, now I'll have to show you some kind of calculation right now, how to get the height at which the block wall will occupy. Okay, that's fine. So right now, if I now move to now open up my calculator right now, so if I open this just now, and then that opens up, we'll now have to do what? Subtract. All right. So right now we have our beam to be 650. Now knowing that our slab depth is what, 150. So minus slab depth of 150, we have the actual beam depth to be 500. Okay, without slab. Okay, knowing that what makes up beam depth, overall beam depth, is slab plus the beam. So if slab is 150 and beam is 300, if you add that together, that gives you what? 450, right? But in this case, the beam depth is 500 and the slab is 150. So the overall beam depth right now becomes what? 650. So now that we want to add wall load on the basement wall. We want to actually find out the exact height that the block wall will occupy, knowing that blocks wall starts beneath the beam and then comes downward. Okay, that's fine. Or start from down and stop beneath the beam. Okay, it doesn't proceed outside the beam. Okay, or let me say proceed go into the beam. It stops beneath the beam surface. Okay, that's fine. So with this right now, we have known that the beam is 500 depth. Okay, now then the height of our story is 3875. Okay, 3875 right now subtracted from 500, what do we have? We have what? 3375 millimeter. Okay, so this is the actual height that the block wall will occupy. Okay, that's fine. So with this now, knowing this, we will now minimize now and then click now on this wall, on end of the wall, right click, and then come here and say what? Edit load. Okay, allow it to load. I know that. Now once it loads now, okay, I am currently using 2022 Protastructure, right? But the next video I'll be using the current version 24 for the design. Okay, that's fine. So with this right now, I'll then come here and click on what? Wall load. Now on this wall load now, I'll have to put in what? My wall unit weight. I'm using a 9 inches block wall, which is what? 225 block wall. So I'll put 3.47 as the wall unit weight. Okay, now this wall unit weight is gotten from knowing that the weight of one block is what? 2.8, and then the weight of plastering 2.85. Okay, then weight of plastering right now is 0.3. Now plastering is of two sides. Okay, so 0.2, which is the external and internal. If you add both plastering together, you have 0.6. So 0.6 now plus the weight of block without plastering, that gives us what? 3.8, 3.47. Okay, that's fine. So with this now, we now have to impute the height that we did. The we had 3375. Okay, that's what we had. Then I come and put in what? Put in the width, the block wall thickness. Okay, which is 225. Okay, that's fine. So with this now, we would then have to do what? Click on this place that says what? Now to now insert the wall on the wall load, which is the block wall load on the reinforced concrete basement wall. You then have to do what? Click on this place here, and then it will show a pink value here. Then just come here and says what? Okay. Automatically, you will see the block wall load will just appear on the basement wall. Okay, you can see that right now. You can see that right now. Correct. So with this now, we have just loaded what? A basement, a block wall load on a basement. Okay, that's fine. So we would then have to do what? Just to be fast, I'll copy this load right now. Right click here and do what? Say copy load. Now we have two load here. One is a soil load and one is the what? Wall load. Now if you want to know how we got this soil load, how we added that, we added this from the for the people that have already purchased other models of this complete course video. You will see how we added the soil load. Okay, so I'll just proceed right now. No, so right now I want to only copy the wall load and not the soil load. Okay, so I'll just come here and click on wall load alone, and then come here and do what? Say okay. Automatically right now it has copied that, as I can see right now, to what? Clipboard. Okay, so to now paste it on all the basement wall, I'll have to click here, hold my control key, and begin to select all the basement wall at once. Okay, that's fine. So just to rotate right now, click on this and this. Now while we are doing this right now, please, if you have not subscribed to the channel, please subscribe. And also, very important, give this video a thumbs up so that YouTube can be able to circulate this video to other younger engineers. Knowing that the dream of making video is to help younger engineers to build their career. So please like this video, because if you don't like, this video will not go viral to other engineers to learn. Okay, so please do help us to do the good, to also like the video. Okay, that's fine. And then if you can do more good, please share this video to your friends and colleagues. If you're a student, share this to your WhatsApp group, which is your class WhatsApp group, or recommend your colleagues to also come so that they can know what we're doing here on Ekidel. Okay, that's fine. So right now I'm almost done selecting all the walls. So with this now, I'll then right click now and then do what? Paste load. Okay, So with this, it will paste all the wall load which we have just done just now. Okay, give it some time for it to post, for it to paste. So with this right now, you can see that we have now pasted all the wall load now. So we have done the first thing that I said we are going to do, which is to show you how to do what, how to insert wall load on a basement wall. Okay, now you can see that I've been saying basement wall, basement wall, basement wall. Okay, that's fine. Now you can see that this here, this wall here is having a soil load. As you can see, that it's having a soil load, which is the soil load. Then since it has a soil load, that means that it is a basement wall. Okay, now since it's a basement wall, we will have to change the model of this reinforced concrete wall, because in Protastructure, green, when a reinforced wall has a green color, it is just a reinforced concrete wall. Okay, then when it has a blue color, it becomes a basement wall. Okay, and then when it has a dark pink color, it becomes a retrofit wall. So right now we are dealing with what, basement. Okay, so we will have to convert this reinforced concrete wall now and assign it to be what, to be a basement wall. Okay, that's fine. So with this now, I will then click on, just select all the walls right now, select all the walls, select all the walls now, just select all the walls here. I can choose to come here, click on this, just to be fast, click on this first one here. Okay, and then hold my shift key. All right, hold my shift key and click on the last one. So I'll click here now. All right, then come down, scroll down, hold my shift key and the last one. Automatically right now it will select all the reinforced concrete wall on the basement. Can you see that right now? That's fine. So with this now, okay, with this now, I'll then right click now and do what, say properties. Okay, properties. It do not display the property of all these walls like a table. Okay, like a table. So on this now, once that displays, I'll go to to the wall model and change it to basement wall. Okay, that's fine. So on this now, I will directly come to this model here. You can see that analysis model, and then I'll click on this place, click on this edit here. Then it will now display the my dialog box again. So with this now, I will then come here, click here, and then choose what, basement wall. Okay, that's fine. I will then come and say what, okay here. So on saying okay right now, it has converted all the reinforced concrete wall to a basement wall, which is carrying the soil load. Okay, that's fine. I will then come, like I said, now it said that it is now all what, basement. Before it was default. Okay, which is a reinforced concrete, just normal wall. I will then come now and do what, say close. Okay, so with this now, if I then click anywhere, you can see that it has not changed. So like I said again, blue color means that it is what, it is a basement wall. Okay, that's fine. So now we have now completed actually the first thing which we are going to do, which I say we will do by doing what, by inserting wall load on the basement wall. So right now, let's now move on to the second one, which is the slab raft modeling. Okay, that's fine. So to model a slab raft in Protastructure, the first thing to do is to go to the foundation level, which is what, Storey 00. Now I'll go to my plan view now and make sure that my plan view is on Storey 00. So if mistakenly you are on any other story, let me say Storey 1 or Storey 2 and all that, just go and click on Storey 00, knowing that Storey 00 or Storey 0 is for foundation. Alright, now on the recent version of Pota 224, you can be able to model a lift pit on the Storey 00, or model a sump tank, or create a model on Storey 0, which is the foundation. Whereas on 2022 and below versions, you cannot do that. So 2024 is more advanced, which we are using here on Ekidel, and we have used it to make one video on pavilion design, and we will be using it to make more videos on buildings having a steel roof. Okay, that's fine. Now let's begin now for the modeling of this slab raft foundation design for this 8-story building. Okay, that's okay. So on this now, knowing for this, let's now begin. So I'll come to my modeling now, and then you can click on what? On slab. Okay, on slab. Now, on clicking on slab now, the next thing I like to do or display the dialog box, which is the property dialog box, okay, which will come out by my right hand side in less than some few seconds. Okay, that's fine. So with this now, the next thing I'll do is to do what? Impute my what? My height or the depth of slab. Okay, that's okay. Now, when it comes to slab raft foundation, all right, slab raft foundation. Now, there are two types of mat foundation or raft foundation. Now, the first one is the beam raft. Then second, followed by slab raft. In all essence, beam raft is more cheaper compared to slab raft. That's because not everywhere you are going to slab. There are some parts you are going to fill with sharp sand. Then you now use a minimal depth of slab of 200 minimum to now place like the German floor. Okay, like the lower floor level. Okay, that's fine for the slab. But then the beams carries the weight of the structure. But in the case of now, don't forget, beam raft also have different concepts. They have what they call cellular beam raft, where the slab is on below and the beam sits directly on the slab. Then they also have what they call inverted raft, where the beams sits on a blinding or on the footing. Then the raft slab, which also forms as part of the DPC slab, is directly on top of the beam. Okay, these are two different concepts of designing beam raft. Okay, but for today, I am teaching you slab raft design without beam. Okay, now on this slab raft design, it has only one pattern of what modeling, but when it comes to analysis, it has two methods of what analysis. Now, using this software, I'll teach you the first method. Yeah, on this software, they have two ways you can do what you can design. Knowing that software is there to help you to make your work faster, but in all essence, you are meant to have manual design experience. Now, when it comes to manual design experience, it's about you knowing the principle of design. So most things we try our best here to tell you the principle and all that, but because we don't have much time, and we don't want to make the video longer. We just say few of them. Okay, that is why we have room for Ekidel mentorship training, where we have one-on-one training with you. So if you want to enroll for Ekidel mentorship training, I would advise, if you can afford it, please enroll. Now, to be able to afford it, we have made a payment plan for installments. So you can pay up to 3 times installments, and the fee for our mentorship is $350. Okay, that's fine. And it runs for a maximum of 6 months training. And after that, we will give you Ekidel certificate for design competency. Okay, that's fine. So, okay, let's now begin now for what we have for today, which is now for the slab raft, which is the level 2, okay, stage 2, okay, that's fine. So with this now, we will now impute the slab thickness, okay. Now, for slab raft, the thickness, just like as you know, you are meant to assume your thickness, but knowing that before you assume, there must be a minimum, just like it is in terms of slab, normal slab, knowing that the minimum slab thickness is 150. That is if you are using UK or European code. But for American code, they have the minimum to be what? 100. For Indian assumes minimum to be 4 times the bar diameter. All right, that's okay. So, but in this case, we are using Eurocode, so we are going to use knowing that the minimum is 200. But for a slab raft design, you cannot assume 200 as the minimum depth. It's not, it cannot pass the design, because what is carrying the structure is the slab. Okay, now we, knowing the height is 8-story building, we will start our assumption at 750 depth of slab. Okay, that's okay. Now, before we assume the depth, I think it's nice for you to know when to use a slab raft design. Now, slab raft design or slab raft or mud foundation is used when the soil, when the bearing capacity of the soil is low. Okay, in my next video, I will have to give you conditions when to choose the exact type of foundation. For example, if you have a bearing capacity of 75, should you use a pad foundation for that? Or if you have something like 50 bearing capacity value, what then should you use? So in my next video, I will give values for this, and then you will see the type of foundations that should come to your mind on what to choose before, once you see the bearing capacity of the soil. Okay, that's fine. So let's now begin now. So type now 750, all right, as our depth of slab. Okay, then we will then move on to, now this place that says what level, leave it as what, 0. Okay, then on this place that says concrete cover, now concrete cover, based on Eurocode, and UK, the minimum concrete cover that you can use for a foundation is 50, right? Based on Eurocode. American will tell you the minimum should be 75, okay? When that's for foundation, or when a member is directly, when a concrete member or a member of structure is directly in contact with soil, the minimum to be used is 50 millimeter. That's for concrete cover. That is in terms of Eurocode and Bscode. Okay, so in that case, since you're using Eurocode, I'm going to type what, 50. Now, most of you will be saying, why am I using Eurocode? Eurocode is the new code. So if you are using Bscode, it is it is given to you to update to Eurocode, because in April 10th, 2010, a letter was issued to all structural engineers around the European region, and those using Bscode, to move or to adopt a new code, which is the Eurocode. Okay, I know that. Now there are many things, there are many benefits of using Eurocode, which I will not say in this video because it will take longer time. All right, okay, that's fine. So right now we have now put on this 50 millimeter as our what, concrete cover. Okay, that's fine. Now you can see this place that says insertion method. Okay, if I click here right now, you can see that we have several methods of what, inserting slab. Okay, now the default one here says bin region. Okay, bin region, but knowing that we don't have a bin here, all what we have here is a what, basement wall. Okay, and then columns. So I'll come here now and then choose what, choose by what, pick points. The best method to insert slab raft is to choose pick points, although you can still use pick by axis, but the fastest and the best method is to use pick points. Let's now see how fast that is. Okay, that's fine. So once I pick points now, I will then come here and then begin to pick the points where I want to insert my slab. Okay, that's okay. So with this, I'll start from this panel here. So now I have seen many people trying to insert their slab rafts. In fact, they'll use one like, okay, just to save time, please just follow me what I'm doing right now on how to model this slab raft. Okay, just follow me right now. So I'm going to model my slab raft now like this. So I'll come now and then click on this place here, click here, right, click here, and then click here, and then come here and then click the final one here. Now you will see that I have my slab. Just hold on. You see my slab will appear here now. Okay, that's fine. Now you can see that we now have one slab appearing here. Now if you look at this whole building now, you can see that we have several panels. All right, this whole team here, this whole places here is called a bale. And knowing that a bale makes up different panels of slab. Now, most people tends to use a bale of slab. For example, they will just model the total place with one slab, the whole region of the building with one slab. Well, I don't know where they got that from, but that's not right. Okay, you must have to divide the bale of slab into panels. Okay, now slab raft design is like the concept of flat slab. When you're doing a flat slab, you don't just use one slab to model the whole bay. So let me say you have 50 meters by 40 meters area of building. That means you just use one full big slab, bale of slab for that. No, that's not done anywhere. You have to divide that bay into panels, into streets of panels. It is different streets of panels that makes up a bale of slab. So that is what I'm doing right now. Okay, that's fine. So with this now, I'll then begin again. I'll then come here, say cancel, then come again, click here, click here, click here, and then click here. Okay, that's fine. And we will have our slab here. Then again, always click on this cancel to cancel the points that you've done before. I will then come again now, and then I have to put the slab here. Click here, click here, click here, and then click here. Okay, that's fine. I have a slab here. Again, cancel again. I'll be fast now. Then click here, click here, click here, and then click here. Now, you might be asking yourself a question: how do I know the where to click? How do I know how to form my bill? Oh, sorry, how to form my panels? Okay, as anyhow you form your panels, but as long as you have divided that bay into different strips of panels, okay, it's okay. Now you might be saying, what is the actual area to like I would like pick? Okay, the whole concept is to divide that bay into different panel, which I'm doing right now. Okay, so just don't allow your panels to be too big. All right, for example, I cannot come and say, okay, I use all this place now, okay, all this place now as a panel. It doesn't really make sense for me. So I have to divide, just take here one, take here one, take here one, take here one, take here. It is even better you have smaller strips of panels that will give you a good analysis. Okay, it will give you a, like, it will make your analysis to be very very what do I say, I don't want to use good in that area, like yeah, it will make your analysis to be very critical. All right, critical, which will be nice, knowing that we design for worse condition than to use just one bale. If you use one bale, it will take the worst condition. If you use one bale, what it do is that it will, once you run a strip of your slab, okay, it will design that strip of slab one here, and then you will just see just one reinforcement, which is horizontal and vertical, just one. But if you have several panels on the bale, you will see that at the portion where the column are, knowing that column where the columns are going to have punching shear issue. Okay, but you will see that that area of column, that particular where the column are, we have different size of reinforcements and different spacing, or the same, or the slab might have the same reinforcement, but it will have different spacing, because coming close to the column there is much stress, much pressure from the column load than going far away from the column where columns are not. Okay, that's fine, which you will see on this design. Okay, that's okay. So with this now, I'll then continue again. I'll clear this right now, then click on this here, okay, and then click on this again. Okay, that's fine. So then again, cancel again, click. Now for you to be able to understand this very very well, I would advise you get the complete course video, because in that place you will see the CAD file of this, okay, and you'll be able to follow me up very well. Okay, that's fine. Else you can still enroll for our Ekidel mentorship training to have a one-on-one training on design of structure. Okay, that's fine. So right now, then come here again right now, click here and then click here and then click here and then click here. So while we are doing this, please don't forget to give this video a thumbs up and also share to your friends and colleagues. Okay, that's fine. So I'll then come again right now. I want to insert here, click here, click here, click here, and then click here. That's fine. And then again, cancel this. Click here, click here, click here, and then click here. And I'll clear the point again. And again, I'll click here, click here, click here. Okay, click here. Okay, and let me just cancel again. Let me just cancel and continue again. I click here now. Okay, and I'll then come here, click here. That's fine. And I'll click this point here, click this point. Okay, and then click this point finally. Okay, that's fine. I'll then cancel again. Sorry, clear the points. Then I'll then come here, click 1. Okay, click 2, 3, and the final place 4. That's fine. Clear points again, and again, click here, 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 here. Okay, that's fine. And again, clear this point again, and again, click here, 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 and here. Now we have a course video on flat slab design. Okay, so you can get that course video. To check our store, you can check on the bio. Okay, check on the bio, and then you will see our store video. Sorry, you will see the link to our online store. Okay, that's fine. Then we have also launched our Facebook page. Okay, which on the Facebook page we will be teaching more on manual principles. That's the principles you have to look out for when designing your structures. Okay, so we have to look out for manual principles, knowing that manual design experience is very, very important, but no one is there to teach you one-on-one, like physical. Okay, no, basically most engineers that are busy don't have time for that. Okay, so with that, knowing that manual design is all about you knowing principles from first principles. Okay, we will be telling you guys most of the terms, rules, and the principles for manual design, which you are meant to know at your fingertips. Okay, so we'll be saying that on the YouTube, on our YouTube channel. Okay, so page. Okay, page. So please try to follow us on that, because we have already started making videos on that, like posting videos on that. Okay, which are short videos. Okay, but very, very good. Okay, so I'll click here now, and then click here, and again click here and here. Okay, that's fine. Clear the points. Come again here, click here, and then click here. Make sure it is sequence, like you must go in sequence. Don't click haphazardly. Go in sequence, either anti-clockwise or clockwise, but you must go in sequence. Okay, so you click here again, and again click here, and again click here, and again click here. Okay, that's fine. Again now, I'll then clear point again, then come here, click here, and click here, and then click here. Now, if you have not subscribed to our channel, please subscribe to our channel, and also please give this video a thumbs up. Okay, so that this video can be able to reach other younger engineers just like you. Okay, that's fine. Let me clear again. I'll click here. Okay, click here, and again click here, and final place, click here. Okay, a slide will be there. Okay, that's fine. Okay, again right now I'll then come again, clear points again. Okay, that's okay, and then I'll come now, click here. I want to have this here. Yeah, correct. Click here, and then click here, and again I'll then click here. That's okay, that's fine. And again, the final one now, we clear this up, then click here. Okay, and then click here. Okay, and click here, and then click here. That's fine. So you can now see that we have now, then on this lift area right now, we are also going to have a foundation slab there. So I'll just clear this right now. I can choose to use bin region now, because there is a wall here. So I can now come and click here. Okay, that's fine. Sorry, you can see I said again that the best one is to just to use the pick point. Okay, pick point. So I'll come again right now, back to pick point now, pick point, and again I click here, 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 and then here. Okay, that's fine. And again, the final one now, clear points, then click here, 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 and here. That's okay. So with this now, you can now see that we have now added all our slabs. Okay, if I now go to my 3D view right now, you can now see what we've just gotten right now. Okay, you can see what they've gotten right now. Now, this is not all about the modeling. Okay, I can see that we have now modeled the slab raft under. Okay, but this is not yet the whole model, because right now slab raft need to spread the load around the building perimeter. Else what happens is that it's going to cause overburden pressure on these retaining walls that are here. So there should be a spread of load around the building perimeter. Most times it's called an apron, okay, or it's called a toe to the retaining wall. Okay, so right now we are going to form another slab again around the building perimeter. Okay, now we would assume the length of that slab to be 1 meter. Okay, that's fine. But you can assume 750, you can assume 800, 850, and all that. But I want to take 1 meter because of the number of stories, 8-story building. So the weight will be much. So I don't want to do many try and error on the height, also on the length of this F1 or 2. Okay, so I want to use 1 meter for that. Okay, that's fine. So I will then go now. Click back on the slab to take back the slab property right now. Take this up again right now, and again I will then come and begin to insert my slab again around the perimeter here. Most times I can choose to choose a cantilever like this and put in my just a 1 meter, but most times too I always like to do what I like to do what to use the same slab here, then offset my my grid lines to the height which I want, to the length which I want, 1 meter. For example, let me just show you what I mean right now. This place now is going to have a slab to be able to spread the load that is coming from this wall, at least spread it a bit. Because right now, this wall is serving as a basement wall and also serving as a retaining wall. Okay, so right now we are meant to spread the load from this wall. So because right now there's a slab here, but there's no slab here. So without putting a slab here, what's happening that this there will be an there will be an overburden pressure on this wall. Okay, so with that I will then come now and then something like this, pick point here, and then pick a point here, and then pick a point here. So let me just show you now on 3D view what this is now. You can now see what this is here. Okay, this is how it's meant to look like. Okay, so with this now, this will serve as what? As a counter effect to the pressure coming from the outside here, from the soil here. Okay, so it will be like a counter effect to at least spread the load, okay, from this wall. Okay, that's fine. So with that now, I will then come back here. Okay, but I said again that I want to use here as what? 1 meter. So let us measure if that's 1 meter. If it's not, we then have to do what? Offset grid lines to 1 meter. So with this now, this is what? 915 meters. Okay, so I'll escape now and delete this. Okay, and then offset my what? Offset this now. Click on this, right click here, and offset this to do what? To 1 meter. I'll press my F2 key, okay, and put a minus sign, and then type what? 1000, okay, and then press what? Okay, enter. Sorry, so this now becomes my line of what? 1 meter. I will make this axis now to be a ghost axis or hidden axis to avoid all these things that's happening here clashing. So I'll right click now, say properties, okay, properties, and again I will then come now and then come here, say hidden, and then off of these stuffs, the bobs, then now say what? Okay, update. Okay, that's fine. So this is now a hidden axis. So I'll work with this. So with this now, I'll then come, click on this slab, right click here, properties. Okay, that's fine. And again, Come now, pick points again, clear this one, then come, click here, click this point here, then come again now. I'll go just the way down here, click here and then click here. Okay, that's fine. Again, clear again, begin again from here, sorry, from this point to this point. Okay, and again move, let me see, can move to here, here, here. Okay, that's fine. Basically it's good to do it column to column. Okay, let me just escape that, remove this. Okay, then click on this, right click here, properties. Okay, clear the point again, clear points. Okay, that's fine. And again I'll click here, one, zoom again, two, now go here, three, and then final place four. Okay, that's fine. Clear points, come again now, come again, here, one, two, three, and then okay, four, that's fine. Clear again, come here again, I will then go all the way down here, one, two, three, and four, that's fine. And again, clear points again, come here, I want to put here. Now this place now does not have this grid line here. Okay, so what I'll do right now is to offset a grid line. Just what I'll do, just watch what I will do now. Offset here first by 1 meter, offset by 1 meter, enter, 1000, enter. Okay, that's fine. So with this now, with this, I'm going to have this, I'll have this now. Then come here, oh, sorry, properties, then come clear here right now, and then come now, click on this, sorry, that's a mistake point, click on this, then here. Okay, that's fine. And again I'll then move on here. Okay, that's fine. I'll then move on, let me see, just go here, yeah, correct, go here, that's fine. And again, clear points now, I have to have something to, okay, this other one need to also go one by 1 meter. Click on this, right click here, offset, go here, this 1000. Okay, that's fine. So convert this first to go to axis so that I won't make a mistake for that. Properties, hide. Okay, that's fine. Update. Okay, again here too, that we did before should be a ghost. Where is this one here? Correct. Ghost axis 2. Properties, ghost axis with the seating axis. That's, and then okay, that's fine. Now this is the point. Okay, and this point. Okay, that's fine. So right now click on this. So with that now I can even do, let me see, I wanted to go like this right now, then just have one slab. Okay, let me see if that will work out. Okay, let me just right now, right click here, properties, that's fine. Clear the points. Okay, that's okay. Then come here, click here, and then click here, correct. Click these points, correct. Click these points, correct. Click these points. Although when the points are too much, the slab will be it might be confusing. Okay, so let me just go here, click here, okay, and then come in here now, click here, correct, that's fine. So I want to have this as a whole slab. Okay, that's okay. So I'll come now, escape, then come again right now, here, okay. Oh, I got it on the wrong side. I don't want, you can see the slab meant to be on the ghost axis. I went to and use the wrong one. Okay, I'll just redo that again. So I'll just clear this right now, click on this, delete, come again here. So you must be careful when you're doing your slab. Okay, click on this right now again, and then clear point again, then continue again here, 1, 2, 3, 0.4, 0.5, 0.6, 0.7, 0.8, Correct, that's fine. Okay, so with this now, I will then move on to this other side now. Now, this place now, I have to offset again. Offset from here, okay? Right click here, properties, sorry, offset by 1 meter, F2, 1000, enter, escape, right click, properties, hidden axis, which is ghost axis, okay, that's fine. And again, come now, here too, offset this also, right click here, offset, come here, F2, 1 meter, correct, enter, let me see, where's it? Okay, I think we already have 1 meter here. They say you can see that they say another axis is already in that location. So right now, this place here is 1 meter. Let me just take that out from here to here, 1 meter. Yeah, correct, 1 meter. So right now, we are going to use do this right now. Right click here, properties, then come now, clear points, then come now, click on this place, 1. Oh, sorry, escape again. Click 1, 2, okay, 3 and 4. That's fine. Again, clear point again. Come now. Click on this place. 1, 2, 3 points, and the 4th one. Okay, that's fine. Clear point again, and get the first point. 1. I pray that's the point. Let me just escape. Then 1, 2, 3. Correct. And then the final one, 4. That's fine. Again, right now, so I have to do this one first. So just escape, click on this, delete, sorry, delete this one first. I click here, delete, that's fine. Then come here, offset this first to 1 meter, offset by 1 meter, minus, it's going backward, 1, okay, that's fine, enter, okay, that's okay. Then come now, right click here, hidden axis, hidden, that's fine, update here, that's okay, that's fine. Then come now, click on this place, right click here, properties, then come now, and then clear help, then come now, click here, click here, click here, and then final place here. That's fine. Clear points, come again now, click here, click here, click here, and click here. Final place, that's fine. Then come now, clear points. Okay, could just cancel. So with this now, we then come over here right now, pick this one by click here, properties, clear points. So I come now, click on this, click on this here, click on this, and then click on this here. That's fine. And again, clear points again. I want to have that again by offsetting this again first. Offset this. Offset by 1 meter. F2 1 1 0 0 0. Enter. Then come now. We now have this. Convert this to what ghost axis. Click on this. Hidden. Okay. Updates. Then do this. That's fine. So with this now, we also have to offset 1 meter here too. But let me see. This is 1 meter. This line here, I don't know what is here. From here to here is what? No, it's not. So right now, offset this to 1 meter. Offset axis. Shift 1 1 0 0 0. Enter. That's fine. Then convert to do what? Hidden axis. Okay. Here. Okay. Update. Clear. Okay, that's fine. Sorry for that. So right now we then have we then model again. Click on this. Right click here. Properties. That's fine. We then model clear point first. We now have here. Okay, that's fine. This point 2. This point 3. Begin here. This point 4. This point 5. Here 6. Here 7. Here 8. That's fine. That's okay. So with this now, we then clear points again. Model this other one here. 1. Make sure you zoom very well. 2. That's fine. 3, 4. That's okay. Clear point again. Again, begin right now. Come here. 1, 2. Then come here. Snap this one. 3, 4. That's fine. Clear points again. Come here again. So very well. Come here. 1, 2. That's true. 3 and 4. That's fine. Clear points again. Then come now. Escape. Offset this again right now by the apron distance or toe distance minus 1000. If you're going downward, enter. That's fine. Right click here, properties, to make it hidden axis. Hidden. Okay, that's fine. Then update and then close. Okay, that's fine. So with this now, click here, right click here, properties, and come here right now, clear points. Then come here, click on this, click here. That's okay. Here meant to be, let me see. Okay, then sorry, just cancel. Click here, click here, click here. Oh, sorry, that's a fucking point. Sorry for that. Click here, click here, click, click, and we have that. Okay, that's fine. Then escape. Sorry, clear points. We are meant to have something here first. Okay, something here first. So we have to undo what? Offset this first. Offset here. Offset by 1000. Enter. Okay, that's fine. Come here. Click here. Properties. Convert. Hidden. That's okay. Then okay. Update. That's fine. Okay, then right now. We now come now. Click here. Properties of that. Then continue again. Clear points. Then come again. Click here. Click here. That's okay. Click here. Click here. That's fine. Clear points. Come now. Click on this. Click here. Click here. Click here. That's fine. And then click here. Let me see. That's fine. Then clear points. Clear. Then offset this last one now. By click here. Offset. By what? By 1000. Okay. F2 minus 1000. Let's go downward. Okay, that's fine. Then we have been converted to what? To hidden first. Properties. Okay. Hidden. That's fine. Updates. That's okay. Here. Okay, that's fine. Okay, right now, let's see what that line is. Where's the line? This is the line. Let me see. This is the hidden line. Correct. That's it. Let me see. Correct. That's it. So right now we are meant to stretch out this line to this grid line to be able to pass this hidden line. Okay. So just do it right now. I'll just highlight all the vertical lines here. Grid line. Sorry, axis here. Right click here. Stretch. Else it will not work. So you must do that right now. Click on this anywhere here. Then just a bit. That's fine. Again, right now, this is our line here. Okay, don't mind this red one here. This one here is just the x-axis. Okay, x coordinate axis. Okay, that's fine. So I'll come now, click on this by click here, properties, clear points. Then come now, click on this point here. Okay, click. This line didn't cross. Oh, that's bad. So click here right now, stretch it out, stretch out, stretch a bit. That's fine. Again, back now, come here right now, properties, clear here. Okay, click here. That's fine. And then click here. That's okay. And then click here. That's okay. And then sorry again. Cancel this. Click these points. Click these points. Click these points. Click here. That's fine. It's okay. Then now we need to offset this one too. Okay, here too. So click on this point. I click here. Offset by 1000 minus 1000. Enter. Convert. Properties. Hidden axis. Remove these bobs. updates. Okay, come back here, click on this, right click here, properties, and come now, clear points, come now, click here, click here, um, click here, and click here finally. Then escape, come again here, click on this, click on the grid line itself, right click here, offset the apron for that, come here. I don't know if that's it. Yeah, is it there already? Is it there already? Yes, it's there already. This is it here. So I'll use that one now. Click on this, right click here, properties, clear points, click here, and then click here and click here. That's okay. That's fine. Clear points. Again, let me see. That's fine. Click here, and the final one. Click here and then here. That's fine. So you can now see that we have now modeled. This is the full modeling for the slab raft. Okay, that's fine. If I now go now we have now modeled. So you can see that we have now modeled the full modeling for the slab raft. Okay, you can see how you have modeled first the slab raft inside the building, and then also provide and like tools, which is slab tools that will be able to spread the pressure that is coming from the building, to spread it evenly. Okay, that's fine. So with this now, let's now go to the 3D view to now see what I've done so far. So you can now see what we have done so far. So this is now, if I now go here and turn off my grid line, okay, my grid line now, come here, turn them off just to have a clearer view. Even turn off the ghost axis, okay, turn this off too. So you can now see how we have now been able to model. Okay, this is now a full modeling of what, of slab raft. Okay, now this video basically for this course has been longing. We have been longing for that, but now we are going to complete this video. Okay, so we have just completed the modeling of the slab raft. Okay, so if you have not purchased the other parts of this video course, because this is a course video where we started from the CAD file up to this very stage, all the modeling, even for the roof slab and everything, and now we are now on the slab raft. Okay, modeling and design. So right now I see that we are going to do first to load the wall for on the basement wall, which we have done, and then model for the slab raft, which we have done again. Now to now proceed to the slab raft design. As you can see right now, we are almost 1 hour of this video duration, and which is basically much long. I don't want the viewer, you view me right now, to be tired of watching this video. So we are going to stop this video here and then continue again for the next part, which is the what, which is to now analyze this slab raft that you're seeing. Okay, that's fine. So I'm going to pause this video right now and then continue again for the next part, which is model 19, because the last one we stopped at model what, at model 17. So this is now model 18. So we are going to enter into model 19, which is the slab raft analysis and design, and then we will now begin to do what, check for pointing failure under the columns, and then see how to add the pointing shear and see how to add the pointing the pointing shear reinforcement and all that. Okay, that's fine. So you can see that we have vast things to do on this building. Okay, we have not even designed this building as a whole. So on the next one, before we begin the slab raft analysis and design, we'll have to run the whole building design as a whole. Okay, then we'll now proceed. We'll now take the results from the building, then proceed to the foundation design. Okay, that's fine. So right now we have completed the modeling of this 8-story building. So if you have not done your own, please continue from here. Now, the reason why this video stayed long was because we used 2018 to do the other part of the course video. So we then discovered that it would be hard for us to be able to explain to you guys how to convert this reinforced concrete wall to a basement wall, because it is not in that option is not in that version of 2018 version. And also the slab raft design is also very cumbersome. So we have to wait till 2022 and all that. Okay, that's fine. So because this is more easier compared to before. So right now, thank you so much. If you have stayed up to this end, please like this video, subscribe, and also recommend Ekidel. We love you. Bye for now. Bye then.